So we're going to do a real quick introduction to the change of base formula for logarithms, something you should have learned in a previous math class before you took calculus. And this formula is useful for us when we do some proofs in kind of the middle of our first half of the calculus class. So I've got the formula up there. It's log base a of b is equal to log base c of b over log base c of a. And we've got some restrictions here on what these values can be. So a has to be a positive number, but not 1, as well as c. C also has to be a positive number that's not 1. And the reason for that is we don't do logarithms in negative bases, and we also don't do logarithms in base 1. Right? So that's why a and c, which is the base of our logarithms, have to be positive, but not 1. And then b must be a positive value. It can be 1, but b has to be any positive number because we don't take logarithms of negative numbers. Right? So that's the basic constraints on what the values of a, b, and c can be. And we also will probably note here that the new logarithms on the right-hand side are both in the same base, some new base c. And our original argument kind of goes right up here and is the argument in the numerator of our formula here. And our original base is the argument in the denominator of our new formula here. And so it's easy to remember which one goes where. The new denominator comes from the base, right? And so that would be the base of this fraction, right? The bottom would be the base of something. And so it's easy to remember that the base of the original logarithm is the one that goes in the denominator. And then the original argument right here, that b value, goes up into the numerator, right? So that's just going to be an easy way to remember which one goes where. So we will real quickly just do a little proof here. Our proof is going to start out with just something y being equal to log base a of b. And so just with the knowledge we have about logarithms, we should be able to rewrite y equals log base a of b into a to the y is equal to b. Right? That's just the exponential form of that logarithm. Right? Where if we were to take log base a of both sides of this, right, we would just end up with y equals log base a of b. Right? That's just one of our log rules. So from there, what we're just going to do, it's going to be pretty straightforward, is we're just going to take the log of both sides of this in base c, our new base, which will end up giving us log base c of a to the y is equal to log base c of b. And we're going to use another rule that we have for logarithms. And you should know all these rules for logarithms, but if you don't, I'll have a video up for those as well. The rule is that a log in any base, doesn't matter, we'll just do common log base 10 here, let's say we'll just do x to the y. And if you have an exponent within that logarithm, that exponent can be pulled out as a coefficient in front of the logarithm. And again, I'm not going to do the proof of that right now, but it's something that you should know, and there will be a video with all these log rules that you should know in it as well. So what we're going to do is we're going to take that y that's right here, it's the exponent on the a, inside of our logarithm. We're going to pull it out in the front, giving us y times log base c of a is equal to log base c of b. From there, we're pretty much done. We're just going to say, well, y is then equal to log base c of b over log base c of a. We're just dividing both sides by log base c of a. Well, if y is equal to log base c of b over log base c of a, and that same y is also equal to log base a of b, that should then tell us that log base c of b over log base c of a is equal to log base a of b, which is our logarithm change of base formula that we just had written up here, right? We've got log base a of b, which is our right side down here, is equal to log base c of b over log base c of a, which is our left side right over here. So you can use this formula to change from one base of a logarithm into a quotient of 2 logarithms of any base you want, as long as it's a positive value and not equal to 1. So we'll do a couple of these just to get the hang of it, but they should be pretty straightforward. We'll start here. We've got log base 3 of 7. We want to convert it into a log of base 2. Well, should be pretty straightforward. It should just be equal to log base 2 of my original argument, right? The 7 is going to go right here, over log base 2 of my original base, 3. That's literally all there is to it. Right, now that we know the formula, we've proven the formula, we can just apply it to turn any logarithm into any base that we might want it to be. So if I asked you with the same logarithm to turn it into base 10, or common log, where we don't normally write the actual 10, right? Log base 10 of x is the same as just log of x. That means base 10, right? So we'll use common log. Right? So we just say this is equal to the common log of 7 over the common log of 3. Right? Just throw that original argument in the numerator, the original base into the denominator, and put it in whatever base you want it to be. So log of 7 over log of 3. We'll do the same here. Same thing. We're going to turn into natural log, right? Natural log, we know, right? Log base e, we call that natural log, right? Natural log of x, right? Logarithm in base e, whatever there's number. So if I want to turn this into a natural log, it'll just be natural log 7 over natural log 3. It's that simple, right? We should be able to do that with any logarithm. So we'll just do a couple more here. This will be our last page here. So if I have log base c of d, and I want it to be in base a, it should just be log base a of d over log base a of the base of c. We want it in common log, and we'll just say log d over log c. You want it in natural log? It's just natural log d over natural log c. And if you want it in base 22, then it's just log base 22 of d over log base 22 of c. And that's really all there is to the change of base formula for logarithms. Pretty straightforward proof, and it's really easy to do. That's it.